Okay, let's try to solve another trig equation here. Here again, we're trying to solve for our variable x, so we need to get it alone. There is a trig function, and the x is inside of it, so the first thing we need to do is isolate the trig function. This time we've got a little bit more going on, so the first thing we'll want to do here is subtract 1 from each side. Always, again, all of our normal equation solving order of operation things work. Adding and subtracting is the weakest link. So now I have 4 times sine of x equals 3. Then I want to divide by 4, and what this is going to do at this point is it gets our trig function by itself, and I have sine of x equals 3/4 or 0.75 if you prefer. Now, 0.75 does not happen to be one of my standard unit circle values, which means that when I want to try to identify what angles make this equation true, I'm going to have to use my calculator. In order to get the x out of the sine function, we're going to use our calculator to identify what the inverse function, so the inverse sine of 3/4 is. This is step 1 in figuring out what value of x is going to work for our trig function. So let's go over to our calculator, figure out what the inverse sine of 3/4 is. Make sure you're in radians. I want all of your answers in radians here. So inverse sine of 3/4, and we can do that whole thing and put it in parentheses or use 0.75. And we get 0.8481. We'll just take that to 4 decimals. Okay, so when we find the inverse sine, we know that 0.8481, that radians, is going to be one of my solutions that will make this particular equation true. When we want to report all of our final solutions, what we'd like to do first of all is identify all of the values from the unit circle. So we're looking for values in between 0 and 2 pi. And chances are there are 2 values for every angle, or for every solution, that lie on the unit circle itself. So if we think here, 0.8481 radians is somewhere here in the first quadrant, so we'll just kind of throw this in here. And what we're looking for is we're looking for something that has the same sign. So we're going to have to use some of our unit circle symmetry. The sign, of course, is the y-coordinate, so we want something with the same sign value. So I'm going to need something over here in this quadrant. So how we figure out, this is where you use that butterfly. We're going up or down from the x-axis. So in this particular case, up this way, it was 0.8481 radians. So to get my other solution, I'm going to have to come up this way from pi. And so my other solution is going to be pi minus, because I want to be smaller there, 0.8481 radians. So we can do that and get an actual value here. So over here on the calculator, you're going to have pi minus 0.8481, so I can just tell it to use my last answer. And I end up with 2.2935 radians. So 2.2, oh, forgot it already. 2.2935 radians. So what I have here is I have 2 different solutions on the unit circle. And that's always going to happen, that we're going to have 2 values within this that we end up with. And so the final thing that we have to do, if the question is just asking you for 2 solutions, this is fine. Sometimes it's going to ask you for all possible solutions. And remember, we can get as many different solutions as we want because our trig functions are periodic. So how we get our other solutions is just add or subtract multiples of the period. The period of the sine is 2 pi k. So we can add 2 pi times whatever multiple we want, as many times as we want, positive or negative, and get all the other solutions that we need. So again, your main steps here as you're solving a trig equation is get the trig function alone, then find solutions on that unit circle that correlate with my values. If it's not a trig function or a value that shows up on the unit circle, use your calculator to find it. Then use the symmetry of the circle to find your second answer, and then add multiples of the period to get your final solution.